All right, before we get into the actual mounter, first, is volume okay? Too loud? Good, all right. I'm gonna go through a quick couple slides talking about automation and mounting and where we are. We talked a little bit about the why we're doing this, but now we're gonna talk a little bit about where we stand currently. If you truly analyze any business system and any manufacturing system, and you look at each step, you have to think about, is it value add or is it non-value add? If you pull photopolymer out of a box, that's value add. If you put an image on it, that's value add. If you dry it, yes, it's important to dry it, but if you dry it for 5 minutes or 3 hours, that time, if you can make it dry faster, it's adding value, but if you're wasting time drying it, it's non-value add. So if you really look at a lot of business systems and manufacturing systems, the things that don't add value, you want to remove to be as efficient as possible. And when we look at the start of the process for mounting, we have to laminate, right? And I can tell you, I'll tell you the story of me hand laminating these plates. Let's just say it wasn't pretty. And 3M lost a lot of tape because of my lamination process of these plates. Doing it by hand is not efficient. So having some system for lamination is something that's always advantageous, whether you've created that system yourself or you're using a laminator to apply it. That will always make your tape application as uniform and as consistent as possible, preventing error inclusions. What you're seeing here is our automated tape laminator for the corrugated market. It has control over the nip, control over the speed, so that you can dial that in for each type of polymer or gauge. It is using the same type of roll that you see on the Flatmount for the application. It can handle 2 different types of tape. If you have different applications, there's 2 tape feeds that can be into it. It will automatically feed the tape through with the plate. It can laminate up to a 0.27 plate if needed. And one of the biggest things that's advantageous for, if you've ever used something similar to this, trying to cut the tape is somewhat of a challenge sometimes. So what we have here is actually an automated cutting system. You're going to see the operator is closing the safety cage and then activates an automatic knife that cuts the tape so you can easily pull that apart. So this is one area where if you can speed that process up and make it as efficient as possible, you're gaining some value in that time. Reducing cost through process, that is really the big thing we're kind of talking about here. The market in the United States is predominantly in the round mounting. There's nothing wrong with it. We've sold 100 plus cylinder mounts. There's actually, many of you have some of our equipment, and we're very grateful for you as partners. But when you look at the process and the human involvement that's involved in doing that type of a mount, there's a lot of setups, there's a lot of steps, there's a lot of movement, and some of that is not value add for the customer and for what you're selling. What we're looking at now as we look at the kind of the future of mounting in the flat is the speed and efficiency that can give you with coordinate information and just in general setup. And we'll talk about the VPP side in a second as well. So optical versus data. You've heard all morning about the importance of coordinates and getting that data from your ERP systems directly to the mounter with as little operator intervention as possible. When we talk about an optical mount, I'm going to use a technical term that I love to throw out there because it's really important to understand. Raise your hand if you know what the term parallax means. All right, that's good. Exactly. Every one of us, if we stood in front of a mirror-based mounter, we would be affected by parallax. Parallax is when you look through glass and something moves. If you take your glasses off and you look at an image, light is reflecting and light is moving around. So I'm going to pick on Rory for a second because he's a hell of a lot taller than I am. If he looks at a mounter and I look at a mounter and we're trying to look at the same spot, that mark is going to be in different places. It's just the nature of it. You can try and look down as straight as possible, but it is going to be in different places because of parallax. It's a technical term, and it's the light that moves. So when you talk about human variation, that is a big part of it. It works vertically and it works horizontally. If I'm looking at something like this, the mark's going to be in a different position.
You need to sue the highway department.
What's that?
I said you need to sue the highway department. You're on the road too close to your ass.
Yeah, that's right. That's exactly right. That's exactly right. So when we move to data-driven solutions relative towards coordinate-based jobs coming from ESCO and hybrid, we're removing that because we're using a fixed camera. That camera doesn't look in different directions. It looks straight now. And that's true with our round product as well as our flat product. When you can remove that variable of the human, you get a much more repeatable and operational solution. Now for probably the most controversial topic of the day. To proof or choose when not to proof. I'm not going to stand here and say you should or you shouldn't. I'm here to say, if you do you understand and does your customer understand the cost of that proof? That is a challenge in the market. It is a very big challenge in the market because you as suppliers to the industry have cost in making that proof. And many of you who I've spoken to throughout the country have reported back to me that often, sometimes more often than not, those proofs are never used. They're thrown out, they're never looked at. And that is cost in time, labor, and materials that you have in your business. How you approach that is your business choice. But until your customer understands that there's a cost to that and a value to that, it's always going to be zero. Because if they're getting it for free and they just like that warm fuzzy blanket and they're not using it, it's always going to be free. So we have the ability to proof and to not proof. What you're going to see today is a way to remove some of the labor associated to wet proofing, to provide very similar types of assessments of graphic condition, and give you a quality report based on the data that we're getting from the computer systems that are being supplied into the machine. So that's enough for me talking. Let's get into the details. If you want to move closer so you can kind of see things, please feel free. I'm going to be showing you the details associated. So thank you to CSW for the mounts that we're mounting on. We do appreciate that. One of the biggest things to think about relative to coordinate-based mounting is how you create zero. Right now, many of you will use a sticker and put that sticker on after you mount. And generally that sticker is applied optically. So if I'm using coordinates and I'm optically applying something after I've mounted it, I could have moved that zero. And if I ever put that back into the machine, I may put it at a different zero, thus changing the whole registration of the job. So on our mounting equipment, both on the newest Opti mounts and on the flat mount, we do have a pin. If you punch your Mylar, which this one is not, which is fine, it can register to this pin. That becomes a mechanical zero for all coordinates going to the mounter, something that you can reference. So I'm going to place the Mylar into the machine. I'm going to close the safety, and I'm going to activate a clamping system. This is a clamp that is then clamping the J-bar into position so that it does not move. I'm going to then turn on the vacuum system. Before I turn it on, because it's going to get a little bit louder, this is a segmented table. There are 4 vacuum chambers, 4 vacuum zones. The primary zone is in the middle. It's about 1 meter wide. The second zone is another foot wider than that. The third zone is the complete back of the machine. And the fourth zone is the foot on the outside. So there's 4 zones that can be controlled with switches right here. I'm going to turn on the 2, the primary and the secondary. And that's actually going to lock this Mylar into place. Now, because I have this zone turned off, I don't have to apply cover film on the outside of the zone. So I've really segmented that down. So our interface works basically in a tree on the side of the layout here, and I'm working top down. So I'm mounting the light blue plate right now. I'm on Mylar number 3, and I'm just going to push F4, which advances down to now set plate number 7. So plate number 7 I'm going to grab out of my pile, which I have prepared. Slide this into place. You can close this to get a little bit closer reach. I'm going to position this into the field of view, and it's beginning to give me feedback to say, am I placing this in the right position? So as soon as I feel that it's in the right position, I'm going to attach the adhesive to the plate, or to the Mylar. And then I'm going to move from what is basically a pre-mount stage into a mount stage. It's got a safety to prevent me from running the VPP into this cover. And it's going to bring the impression roller down onto the center of the screens, center of the marks, bring it up and then out of my way. I then can close this, reach, remove the cover film, and lay the plate down. Thank you, Mike. Open my safety and hit enter. Now it's going to auto mount. I, as a human, should be doing something else at this point. I should be prepping my next plate while it's mounting. And you're going to see that it's actually going to the middle of the plate and rolling out. So it's not creating the possibility for an entrapment of air underneath. After it's done, it's going to go, provide a check at the end, give me the okay, and then I'm going to advance to the next plate. So now it's plate number 8. Plate number 8. Gonna slide in here. I'm getting that feedback as an operator that I'm placing it in the right place. Again, moving it to the center of the marks, roller comes down, back up, getting it out of the way. And again, I should be moving on to the next plate. The intent here is, again, I should be doing things while this is doing something else. This works just the same in a single plate as it does in patches. This table does have the ability to do 69.9 inches in depth, and it will bring the cameras 125 inches apart from each other. Going to move on to plate number 9. Again, to the middle, up and away. This is a newer feature that we have relative to the auto movement of the actual impression roll during the mount. What you are seeing right now is going to be some of the technology that we're going to be releasing at Drupa in the coming year. So it's a little bit of a treat for us to bring this to the United States before we even get it to Drupa. Again, to the check, That one we can even remount. If it slipped a little bit, I may have not have brought it up all the way, but we can go back. So I can move this out of the way. Could I get the cover films? And show you how easy it is to remount. Because we're using coordinates, I have the ability to go exactly back to that same spot and choose to remount it if I would so choose. So I am going to go back to plate number 9. Well, plate number 8 first and then back to 9. And then that allows me to go exactly back to that same spot. And I can remount it. I think what I did was I didn't impress it down enough. Thank you, Mike. And again, as Mike mentioned, from a mark system standpoint, and this is true with both ESCO and hybrid, the coordinate is, the number is always going to be in the upper corner. That helps to prevent you from mounting it upside down. I'm going to advance to the last plate. Pushed the wrong button. Safety. Again, rolling from the center out helps to prevent that air inclusion underneath. And then now that we've mounted the final color of the mount, it's doing the final quality check, and we can go into VPP. So what you're seeing now is the 2 previous scans from the previous colors. We did black and dark blue prior. And we are going to be scanning the light blue at this time. So I'm just going to push scan Mylar. The machine now is moving into the scanning stage. It's kicking the left camera to the left and now bringing the VPP head into position. At this time, I as an operator should again be doing something else, because this will take about 2 to 3 minutes depending on the size of a scan. It is completely scanning the entire mount. It's about 10 gigabytes of information per color. It's a 42 megapixel camera that's scanning at this point. Now, it's important to understand that what we're trying to do here is scan the surface of a translucent material and begin to determine what's printing and what's not. How we do that is, as was mentioned in the previous presentations, we're using the PDF as a mask to mask out the background of all of the graphics. And that allows you to have a visualization of what the surface is. Now, is this going to be to the fidelity that's going to allow you to check halftone dot? No. Is it to the ability for you to look at attributes of low spots in print? No, because this doesn't print. But I would argue if you're trying to find the low spot in a liquid plate, and you're making that plate, cutting that plate, laminating that plate, proofing that plate, and putting all the labor and time into that plate, when you know that there's a flaw in the density of the film or the scratch in the glass, you should be fixing it at the root level. The analogy I use, it's like buying a Ferrari and putting a dent in the quarter panel and hoping by the time that the customer gets it, you see the dent in the quarter panel. You really don't want that. So as it's finishing scanning here, the other thing that we're doing, you'll see that we talked about a 3-color mount, and there's actually 4 colors in here. And the 4th color is labeled die line. That does not have any mount information because we're not mounting the die. But we need to attribute the PDF of the die to the scans that we have so it will lay a complete composite together. That die would be both the cut and the crease. So sometimes it may have to be combined depending on your Illustrator layout or your PDF layout. Once this is done, and it's just about done, it's going to process the data. And what you're going to see is a full scan of the mount that we have right now. But what we need to do at this point is we need to mask out all of the non-important information, and we do that by adding the PDF for this particular layout. So we have the light blue PDF. We're going to open that. And what you see on the left is the actual scan. What you see on the right is a recomposite of the PDF. Now, as I zoom in here, what you're going to see is we have the ability to interact with that PDF. I'm going to zoom in to this little mark right here. And because we already imported the previous 2 colors, we have the image offset already established from the previous mark. But what is able to be done is I can choose to move this PDF in association to that scan because I am re-registering it relative to that. Once I have it in the place that I want, I'm going to select it, and that begins the process of actually punching the data out and giving me that scan on the left. Again, we're processing large scan files, so it does take a second or 2 here to work through the data. Now, as I zoom out, you're going to see we now have a trapped representation of the scan to the PDF. So this is the point where the operator has the ability to interact with this, look at the graphics, say, does this look okay? And am I seeing the information in the plate as associated to what I'm expecting? The one thing that's not yet in here is the die line. So as I zoom out, I already have the die line loaded, but I can turn on that, that function for the proof print to have that displayed. And what you're going to see is it's then going to interlay the die line on top of these scans. We didn't scan a die line, it is physically a one-to-one of the PDF. So because there's no mount scan, it's just going to lay the PDF right on top. And now you see there's a die structure associated to it. Okay? what the quality report looks like from this is this file, which is a multi-page PDF. So in here you will have your job-specific data, which will be as a part of the data file that you supply to the mounter. It will then begin to show you the quality report of the quality inspections per plate, whether it's one mark per single plate, or if you have patches, it will be 4 sets of marks per color. So plate number 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 plates. As soon as it shows that, it will then show plate width distance, so it's capturing data from the image recognition to say what the plates are relative to those marks. And then it goes right into the virtual proof print. So you will have on here a composite scan with the die line, and then separated scans with the separations at the bottom. You'll notice that where there is halftone dot, obviously this is a scan of a photopolymer plate. What we are doing is we are doing our best representation of where the screen is. Like I said, this is not going to represent the halftone dot. It is going to say where the screen ends based on where the PDF had data to chop out. Any questions so far? I've kind of gone through that a little bit fast, but any questions at this point?
Does it tell you how long the scan took?
It does not at this time tell you how long the scan takes. Is that something that we could possibly do potentially? Yes.
So when you look at this scan, you're comparing this scan, is that a purely visual analysis you have to do, or does it flag any?
For those who can't hear, the question is when it's doing the visualization back, if I go back to here, when I'm doing a comparative here, this is purely a visual assessment by the operator. At this time, it does not have any intuitive interpretation or AI to say, hey, you're missing something here. But I will show you in a second what it looks like when you do something wrong, and then how it visually happens for that, how it visually represents that. But before I do that, I want to show you one additional thing that is functional on our flat mounts as well as on our other units. I'm going to go to plate number 10. So if you do have an OptiMount now, this is a function that is capable for that. You have the ability to choose as an operator, I want to take a snapshot of this picture. So I've taken a picture of this plate, and now just for noise level, I'm going to turn off the vacuum so people can hear that. I'm going to move this out of the way with the safety, of course. Move this out of the way. You'll see I now have an image of the plate that's there. I'm going to remove this plate. This plate comes back and I now need to mount this. I'm going to choose to go back to the plate number 10. I have a new plate number 10, and I can lay this in optically into it. So this is an opportunity for you. If you take pictures of all of these coordinates before the unit before this Mylar is taken off the machine, it will store those pictures in relationship to those coordinates. Once you cut them off, you now still have a picture of that. If that separation has to come back to be redone, you don't need all the other separations. You have all the data, you have all the positions, you have the images of where the marks are. You just need to make a new plate and position it in place. You can also do this with objects. So if I am trying to register that, so I go to that upper corner because I've cut off the marks, I can move the cameras to a position, and now I can lay this plate into that image of an existing graphic. As long as that graphic is straight across, I can take specific reference points and mount it exactly into that spot. So you have that ability. This is called image overlay. We have the ability to do that on OptiMounts and on the flat mount. All right? Any questions so far?
So it's not saving all of the snapshots. You're specifically asking it to save certain ones.
You have to, you as an operator, so the question is, it's not automatically saving it? No. You as an operator have to choose that. Okay. Is that an area for us to improve on automation? Yes, it is. And that's something we can certainly look at. Okay. What does it look like if we can look at the screen back over here? So again, virtual proofprint is a ability for you to look at the graphics in a comparative way. But if I mount something upside down, I'm still going to use that PDF mask, which is the kind of the gold standard of what we're shooting for. But if I mount it upside down, there's definitely something wrong. I, as an operator, when I'm doing my check and doing that comparative left to right, should be able to see that difference. So that's where we see the virtual proofprint as a way, in conjunction with the quality information, right? No error should leave the point of its origination. If you have good quality data coming out of Prepress, you're mounting that into, or loading that into the mounter, and you're mounting into those coordinates. You have a quality report that you can provide for every plate relative to data. You have the VPP, which is then a visualization that somebody can use. You can send this PDF to the customer before that mount has ever left your facility. Now, obviously, the bigger the scans, the greater the size from a transfer standpoint. I believe these two PDFs that you have are about 30 megabytes, so they are a bit large. There may be a little bit of room for compression there, but we do our best to balance quality versus compression rate. But if you have systems for your clients to view PDFs of large size, this is not too dissimilar from what you have. All right. As I kind of round up here, I just want to give you a world perspective. We are talking about something that's fairly new to, it's a paradigm shift here in North America. As far as AV Flexologic's corporate output of corrugated machines worldwide, these are the machines that we have worldwide. There are 232 corrugated machines worldwide. Of that, 105 of them are OptiMounts, or in the round mounting with mirrors and moving cameras. This is the 100th flat mount that we have sold into the United States, or into the world. And then looking specifically at the flat mounts worldwide, in the continental European market, there are 60 flat mounts. There are 11 here in the United States, or have been purchased here in the United States. So it is a pivot in the market from an efficiency in proofing and speed of mounting. You don't have to use this on a 60-inch mount to get your plates to lay down. You can get it laid down without hurting your shoulder. Any questions?
Okay. Do you have to run the virtual proof right after you do the mount?
You have to do it before you take the mount off. So the question is, do you have to run the virtual proof right after you do the mount? You can, that's the best time to run it because it's in register. It's in register to 0. If you chose to mount all your colors and then put it onto put the Mylars back onto the machine, you could scan it one after the other and just VPP it a job. But the best time is after you mount all the plates for that color, VPP, scan that color, load your next Mylar, mount, VPP, and so on and so forth. Good question, thank you. And, what's that? Kind of, yes. It's about registering the Mylar next to each other, and that's the hard part. Any other questions?
question because I know the answer, but many times in this industry, maybe you covered it and I missed it, but there's a lot of repair work. People have to bring the Mylars come back in, and I thought maybe you could show some of the shortcuts that we have to help with that repair work.
Sure, sure. So from a repair standpoint, I just illustrated the ability to coordinate base, go right back to that same mark. If you, and every corrugated color is different. Some people cut off marks, some people don't. Some people cut off some marks and leave some on for printing registration marks. If you do have printing registration marks, you can create additional plates that are just used for inspection, that are just used for overall position. Capturing those is a good way to have a reference point once the marks have been cut off. You can go to those. The ability to remove the Mylar itself and bring it back into position is important. Now again, I don't have a pin to register, so there's a little bit of movement that's going to happen there. You do have the ability, if you do have existing marks, to move the unit to a specific plate. So if this was my printing mark, I can bring that Mylar in and move it to that existing plate if I want. Tension it, clamp it, vacuum it, and I'm right back into that same position. I can then remove the plate, take some cover film, process a new plate out of the processor. Yeah, I need a little, yeah, thank you. Go back and remount the plate very easily. Because you are using those coordinates and you're referencing those same spots over and over and over again. But it all centers around where your zero is. The delta shift that can happen because you're not positioning it in a zero mode really affects the overall. Now that's deck shift in a printing press, but it is the ability to do that. So, any other questions?
So the handle is to turn it if you're mounting on the sides? The handle on the
Yep, so this can spin around and go from the back if you're trying to reach, let me turn this up. If you're trying to, you have something that's 60 some inches in the back, you can spin it around. This can be modified to spin 360 degrees around. But there's things to also consider as you're looking to work with the unit. Some of it is also process solutions, right? So the vast majority of the plates are going to be mounted on this front part of the machine. But if I chose to mount something here, but it's going to be way back there, you can have a slightly longer plate, and I can manipulate that plate. Even though I'm not as tall, I can position that plate this way and get it into position and drop it. Yeah, you can have more length to it. That gives you the ability to manipulate it. If you are doing smaller units, it is a little bit more challenging. Full transparency, putting a cert box 60 inches, I would probably work from the backside for that if I was just doing that little patch. And as you work from the backside, left is right, right is left, because you're looking at the camera from the opposite direction. Yes, so thank you for that. This is a 135-inch machine for Mylar. It's mounting, cameras can move about 125 inches apart. The zero is here. If you wanted to mount a 200-inch width mount, you can move this zero 50 inches over here, and now I have all that space to put coordinates on. You then move it 50 inches to here, and now I have that same amount this way. So by splitting your Mylars in half, because let's be transparent, a mount that big is not going to have a 200-inch backing film or a Mylar. You're going to, out of user interface, you're going to have a smaller segmented backing to that. But that's a good point. Thank you.
Is there a way to set? Is there a trick to setting up your mounting paper with the gap in it?
So this is my opinion, but I'm not a professional mounter. I'm just a guy who talks a lot. What I like to do is I personally will laminate my plate, pull back my cover film to a point where it's past where my marks are, take a razor blade, cut it, and then put it gapped so that I have it that way. I personally don't like to score the back and take 1 inch out for two reasons. One, you can cut into the back of the plate. Two, you still have two pieces that are like really well adhered with, in this case, 3M tape directly to that plate. When you get to the point of trying to remove it, it's a little more challenging. It's a lot easier to pre-remove it, put it right back, and then go to the mounter. Just from an efficiency standpoint, you're not wasting any time, you're not wasting any material, it's just more efficient that way.
You can use tooling.
What's that?
You can use tooling. You can get a blade that only sticks out a certain amount.
Yep.
That's what our guys use.
Yep.
No tool about this big.
Okay.
You can get different thicknesses, so just get the thickness of your
The backing film?
Just cut it carefully.
Yep.
Don't go like this.
Yeah. And that's the challenge is your seasoned veterans probably do that really well, but the guy that you just hired last week, he's probably going to score the back of the plate, right? So I'm a big fan of workflows that work for everybody and making sure that when you, and there isn't a right or wrong way of removing cover film. As long as it works, it doesn't matter. It's all about removing air is the key thing.
How close the pins get?
3.94 inches. So really tight together. And Mike mentioned on his demonstration that one of the separations was red. What that is I don't know if I can, I'm breaking every rule of demonstration right now, and I'm going to try and live show that. So I'm going to go here, I'm going to create a new, sure. So the question is centered around how close can the cameras go together? And what I'm going to simulate here is a plate, which is, we're going to do this one, and it's going to be here. And the plate width, I'm going to make 3 inches, and I'm going to hit save. So you see that it's yellow. What that means is it's moving into single camera mode. So I'm going to go to mount. It's going to go to that particular plate, or that particular Mylar. I'm going to go to that particular plate. And you see it's moving into a single camera mode. What that means is, and I might not have it turned on, I bet you I don't have it turned on this machine. Oh, yeah, I do. Okay, so if you see in this bottom corner, there's mount left target, mount right target. So if if I were to simulate this, because I don't have a plate like that, but I would put my plate here, get it into position. It's not necessarily going to give you a quality report associated with this because it can't quality report with one camera. But I, as a human, can make a decision to say I want to move it there. Now, if you watch the left camera is going to move 3 inches over for where the 3-inch mark would be. So I'm using that same camera to go back and forth. This is a function that is available on OptiMounts as well, but you are very much reliant on the human to place it straight. This is good for small color cert things, small barcodes, whatever, marks, things like that, but it is a function that's there. It's just not something that we can quality control because it's the same camera running the two mounts. But if the hybrid software or the ESCO software were to produce a plate which is 3 inches apart, you can still mount it. It's just going to be one camera. Okay? Any other questions?
Are those the only controls if you're mounting a plate?
These are the only controls. Yeah, these are the only controls. But from the standpoint of, if you think about the overall process, other than removing the backing film, which once you get it into place, you can move the cylinder out of the way. You can pull all that, and then you just come up here and it'll auto mount afterwards. So.
No issues with different substrates like R-back, foam back, 125.
So this is the most advanced vacuum table that we have on the market right now. With the segmented the segmented table. We know that the two vacuum systems that we have on existing flat mounts work really well up to like 30 mil. You do have to mask the outside to help create that vacuum. That's why we moved to the segmented system to help improve that. Whether it's R-back or not, that doesn't affect it. It's more about the rigidity of the memory that's in that Mylar. Certainly these thinner backings are very easy. It's that thick 60 thousandths material that has a memory coming off the roll. That becomes a little bit more challenging. If it has a memory, there's only so much that vacuum can do. A little bit of tape and you're away in running. So.
How does this do with eye plates or mask plates?
So an eye plate, as far as, are they patched or one big eye plate?
Yes.
Okay, so the attributes of a patched eye plate versus a full eye plate. Right there you see, this is a full plate of the exact same job. It only has 2 marks on it. So an eye plate that is full would only have 2 marks on it. It wouldn't have marks within it. And the eye plate, even though it's a thinner backing film, would be laying flat, and you don't have that drape from going over a roller. You're just manipulating that full plate as a unit. The patch plates would be approached the same way.
How does the vacuum system handle foam back to mark?
So the question relative to foam on the vacuum side backing, that is something that we've seen good performance with, but it certainly depends. There's a lot of different foams out there. If something's very porous, it may bleed through the foam. But again, this is the strongest vacuum system that we have with the 2 vacuums as well as the zone type of application. How does mounting a big plate? I would have to strip one, so if we wanted to see that, I have to get some backing film, so if you can just hold for a second. We're going to set this up.
Before you pull that off, can I get a picture of you showing that it's verified?
Sure.
Can I get a picture of you?
Sure. 1 second. Let me go to the mount. It'll just be a non-stick plate, but it'll give the same thing. One sec. It's because this one doesn't have the backing film. We'll just use this one.
I just want to see it and say okay.
Yeah. Here it goes. Perfect. All right.
Why am I thinking of Indianapolis right now?
Yeah, it's pretty much the same thing. I'll adjust it. I'll just wait.
Good.
All right, so the question was, how does a big plate look to mount? So what I'm going to do is I'm going to go to my job list, which has all of the plates that we have loaded here. I'm going to load our full plate. Now you see that the hierarchy tree has a different setup. Each plate, each color Mylar only has one plate. So we are going to do the dark blue. I'm going to turn on my vacuum. Going to go to the Mount tab. I'm going to select the plate that I want to mount. It's now moving the plates into position relative to the coordinates for the full plate. So this would be to like an I plate, a large I plate would be exactly the same. Getting the coordinates into position here. Again, my plate number 2 relates to the color that I'm doing. Getting the mark stuck into position. Click OK. Brings the impression roller down, back up, and out of the way. I'm going to bring the photopolymer forward so I can remove the cover film. And then I'm going to slowly lay the plate down, helping to get all the air out. Again, the same, towards me. Now you're going to see during the lamination of this is the limit of what the machine can do relative to impression. Because this graphic is very close to the lead edge, that green roller can only come so far because of the limit of the machine. This physical machine is 8 feet wide. A shipping container on any sea vessel is 8 feet wide. So we physically can't have the carriage go any farther forward. So what you're going to see is it's going to stop short. You can see it's going to come as far as it can and then limit out. And then as that would be the only thing that the operator would need to brayer out. That's just the physical limit of the machine. So that is the lamination of a full plate. Any other questions? Does it come in purple? Anything's possible for the right price.
I know a guy.
Yeah, we can make it any color you want. What's up?
Are you definitely locked into those targets, those type of targets?
That is really, I guess, a question for the software team. So the question is, this would be both for ESCO and hybrid. The question is, are you locked into this coordinate system?
This target.
This target.
That particular.
We're not. I mean, you can change what you need. We can train them to look at a different target. So there's different ways of doing that. Whatever you need to do. The only thing you're locked into is in that corner. That's where we're putting the number. Because that's a part.
Is there a reason that you,
You can flip that plate upside down and step behind your car.
if the number is in the upper right, and you're always mounting that number in the upper right, you're orientating it the right direction, right? So there is opportunity to have different marks, and we can look at different marks. So our image recognition software can look at different systems, and we can have a different mark for the left and the right, but that's really a computer software side.
You can apply them.
But that would be error-proofing that flip. It wouldn't give you, if you had a different mark on the left versus the right, it would not give you the okay because it needs to see the one mark on the left and the other mark on the right.
So the awesomeness is that it will also say okay, but still not be okay. What is the tolerance?
It is adjustable up to what, so the question that's asked is, what is the tolerance for the machine? This is an automatic mounter, but it is a human that is actually positioning the plate. It is automatically telling you if the marks are in a position of the tolerance that's set in the machine. The current tolerance is set to plus or minus 0.02 of an inch, 50 micron. You can tighten that up and make it to whatever level you want, but your operator is going to be adjusting that. If you look at these marks, they are roughly about 1/8 of an inch in diameter, and we're making that about 5 inches on that screen. So 0.02 of an inch looks like a lot over here, but it's a really, really fine when you're talking about impression on a corrugated plate, or registration on a corrugated plate. Any other questions?
So let's just have a scenario where you have a piece of 30-point PVC
Okay.
at the end of the roll. So it's
Okay.
got memory.
It's got a memory in it. Yep.
How does the vacuum?
Okay.
On
So
a large piece.
sure. So the question is, if you had 30 mil PVC at the end of a roll, so it has a lot of memory and it's got a lot of natural curl. The application, I would say, for that, you would still stitch the lead edge bar on there. This will work with all different types of E-wall bars and other types of mounting systems. You would want to lay that down. The vacuum in that scenario is not going to be able to hold it by itself. It's probably going to need a piece of tape or two along the side to help hold that in place. But this being a segmented vacuum system with the different zones that are in it helps to keep that vacuum where it needs to be.
Can you cover the, like, let's say if there are times where you, like, use scrap to cover up
Yep,
spots?
so because you can turn those zones off, these zones aren't working right now. They're zoned off. That's what the switches are. So there's 4 zones. We'll back this out. So the zone 1 is about the size of this plate right now. Zone 2 is about 1 foot beyond this plate and within about a foot of the back. Zone 3 is all of the back. Zone 4 is this area over here. So we are controlling that with these switches to turn the main vacuum on for 1 and 2, and then the auxiliary ports open up for 3 and 4. So 1 pump is driving number 1, 1 pump is driving number 2, and then if you want the other ones, the vacuum is split to the other 2 chambers. Yeah. And older systems, for those of you who do have our equipment, older systems, that would be what you would have to do. You would cover film the vacuum. They had double pumps, but we didn't have them zoned. So the new advancement on this one is a zone table. So the question is, how deep is the table? If I back up to here, these are the specs on the table, but it's 69.9 inches deep. And it will scan up to 70 inches deep because of how that scanner works in its field of view.
So if you have, let's say, a plate way,
Yep,
would that be able to turn around?
yep,
Okay.
yep. It can be orientated to turn around.
Okay.
Yes. Any other questions?
Is the roller manual?
The roller manual.
Put like a piece of mylar down and squeegee out the...
You can, yep. So I can kind of simulate that. If the question is, can I operate the roller by hand? And you absolutely can. So if this is my mylar, I'm laying it down, I'm getting it into the channel. I can bring that roller all the way up. I have not engaged the lock, and I have not engaged the vacuum at this point. I can bring it all the way to the front. It automatically slows down so it doesn't come to the end. Okay, that's the max. I bring the impression roller down, and now I can put that tension and pull it all the way back. I just can't operate the clamp while that's moving. As long as that stops, now I can activate the clamp. Activate the clamp, that's now locked in place. I can turn the vacuum on, and I can fully roll the plate all the way out. Any other questions? All right, well, again, I thank you all for taking the time to see the machine. Bruce and Danny are here as well if they have any questions. If you have any questions, please let them know. Thank you very much.